The journey of every tire begins in rubber plantations, where mature trees are carefully tapped to release natural latex. Fresh latex is collected immediately, sealed to preserve purity, and prepared for industrial transport. At the factory, liquid latex is unloaded into insulated tanks where temperature and flow are tightly controlled. Laboratory technicians test each batch, ensuring chemical balance, elasticity, and consistency. Approved rubber is processed into solid sheets and stored for continuous production flow. High-tensile steel wire arrives, engineered to reinforce tires under extreme forces. Rubber compounds are mixed with carbon black and additives inside massive industrial mixers. The newly formed compound emerges as dense sheets, inspected for texture and uniformity. Calendaring machines compress rubber to precise thicknesses measured in millimeters. Steel wires are braided into flexible cords, forming the internal skeleton of the tire. Extrusion machines shape rubber into treads, sidewalls, and inner liners. Inner liners create the airtight layer that allows a tire to hold pressure reliably. Steel beads are formed to lock the tire securely onto the wheel rim. On rotating drums, rubber and steel layers are assembled into a green tire. The tread is applied with laser-guided precision to ensure perfect alignment. Each uncured tire is inspected for symmetry and structural accuracy. Green tires enter curing presses where heat and pressure reshape their molecular structure. Vulcanization permanently forms tread patterns and strengthens the rubber. Fully cured tires emerge hot and complete, handled carefully by automated systems. Cooling tunnels stabilize the rubber, locking in performance characteristics. Excess rubber is trimmed away to achieve clean, precise edges. Uniformity testing spins each tire to detect imbalance or deformation. X-ray systems examine internal layers invisible to the human eye. Endurance machines simulate years of road stress in controlled conditions. Final visual inspections confirm flawless surfaces and branding. Sidewalls are laser marked with specifications and regulatory information. RFID tags and barcodes enable full life cycle tracking. Automated packaging prepares tires for bulk handling. Robotic palletizers stack tires with precision and stability. Finished tires enter high-capacity warehouses awaiting distribution. Inventory systems balance global supply and demand in real time. Loading docks move thousands of tires daily with synchronized efficiency. Logistics software optimizes transport routes across regions and borders. Transport trucks depart, carrying tires toward markets worldwide. Distribution centers sort shipments for regional delivery. In showrooms, tires are displayed as precision-engineered safety products. Customers compare performance data before making informed choices. Sales systems register each tire, maintaining traceability. Selected tires are prepared for professional installation. Technicians mount tires using automated torque-controlled equipment. Balancing machines fine-tune each wheel for smooth performance. Final inspections verify pressure, alignment, and fit. Vehicles are returned to customers, road-ready and safe.
New all-season tires properly seated.
Used tires re-enter the system at recycling facilities. Shredders break tires down into reusable material streams. Recovered rubber is cleaned and refined for reuse. Steel is magnetically separated and recycled. Reclaimed materials are blended into new production cycles. Environmental systems monitor energy, emissions, and water usage. The factory operates as a closed, optimized ecosystem. Even at night, automated production continues without interruption. Research teams develop next-generation rubber compounds. AI simulations refine tread designs before physical testing. Prototype tires are assembled for experimental validation. Cold chambers test performance in extreme winter conditions. Heat chambers simulate desert temperatures and sustained friction. High-speed rigs push tires beyond normal operating limits. Motorsport tires receive specialized tuning for maximum grip. OEM factories receive tires directly for new vehicles. robotic tools secure wheels with absolute precision. Military tires are tested for heavy loads and impact resistance. Agricultural tires are built for massive torque and durability. Mining tires are engineered to survive extreme terrain. Autonomous robots maintain factory machinery continuously. Energy systems optimize power consumption across operations. Water recycling facilities reduce environmental impact. Advanced filtration captures and treats industrial byproducts. Shipping ports load containers bound for global markets. Customs scanners verify shipment integrity. Overseas warehouses distribute tires regionally. Regional hubs supply local dealerships efficiently. Retail spaces present tires as essential safety technology. Service technicians install tires with speed and accuracy. Final checks confirm road-ready performance. Customers drive away, supported by hidden engineering. On city streets, tires absorb impact and maintain control. On highways, they endure speed, heat, and load. At end of life, tires return to recycling systems. Data confirms reduced waste and improved sustainability. From rubber tree to global roadways, this is how tires power modern mobility.